All right. And because this is an entire show about rockets, I'm going to need some help with some countdowns. So for our first, everyone gets to participate, it's okay. So we are all going to get a nice big countdown here for 3, 2, 1.
It's gone somewhere. I don't know where it's at. It's gone.
I'll get that later. So what do you think, R2? Is that a good one? I think R2 likes it. I think R2 likes it. So I know it didn't look like an impressive rocket, but it actually was very important to show you guys that, to help us understand how rockets move. So after I let the balloon go, who can tell me what happened? Yes.
The air is kind of like the thrust that pushes itself into the air, and then it went all the way around. Where the thrust pushes it, it's the direction it goes.
I couldn't have explained it any better myself. That's awesome. So the air was the thrust for our balloon, and it pushed, as the air came out, it pushed the rocket forward and all over. Exactly. So, the air coming out provided something called a force. A force is just a push or a pull. Now, has anybody ever heard of this guy named Newton? Had kind of floppy hair, got hit in the head with an apple. Yeah. He came up with these laws that describe motion and force. And for our rockets, the most important one is his third law. For every action, there is an equal and opposite reaction. So, let's demonstrate this a little bit further. I know, I have the best rockets. All right. So I'm not going to fill this one the whole way yet. I'm going to fill it half. How high up do you think my rocket will go when it's half filled with air? I mean, high. You think it's going to go to the top of the screen, the bottom screen, all the way up? In between? That's a pretty good guess. All right, R2, are you ready? He's ready. Are you ready?
Yeah!
Excellent. All right, get another countdown from 3,
3, 2, 1.
I know. So, I couldn't see it very well. How high up did it go? About halfway-ish. So, if we wanted our rocket to go higher, what should I add? Pull it all the way down. I need to add more air and thus have more force. You guys are really good at this. Whoops. It happens. Has anyone ever watched a rocket launch? They had one, not this past October, but the October before that, where they were testing the Orion module. Sometimes they have to do what's called scrub emission, where it means they have to redo it a different day because something goes wrong. I just had to scrub mine. So, I've got it all set. We're ready to go. And you know what comes next? 3, 2, 1. Perfect. So you're absolutely right. I had to add more air in order to get it to go higher. Now, there's only what do you guys think? Do you think air would make a very good rocket propellant?
Kind of.
Kind of? If we wanted to get it to go all the way to outer space? No. See, when we want to launch a rocket into outer space, say to orbit the Earth, go to the International Space Station, travel to distant planets, we have to overcome this little thing called gravity. Yeah, little thing called gravity that holds us right where we are. Now, you ready to have your minds blown? In order for a rocket to reach what is called escape velocity, or in order for it to get out of the reach of gravity, it has to be moving at 25,000 miles per hour, or 34 times the speed of sound. It has to go really, really fast. So, in order to get our rockets to go really, really fast, we have to rely on a very interesting mixture of things. So, in order to propel our rocket up, we need a propellant. And most propellants that you're going to find are made of two parts, a fuel and an oxidizer. Now, oxidizer just provides extra oxygen, while the fuel reacts in the presence of oxygen. So, for this one, I am going to need a volunteer to help me with something. No, sir. The hat. Oh, it's a Teenage Mutant Ninja Turtles hat. That's awesome. What's your name? Lincoln? Everyone, give Lincoln a huge round of applause. So, Lincoln, what we are going to do is we are going to make an Alka-Seltzer rocket. So, what I have here is a nice big chunk of Alka-Seltzer. Break that in half. Now, you see where this little line is that says number 10? I would like you to add water in up to that line. My finger by it so you can see it. Oh. That's okay. All right, next big thing. I want you to put that so that it sits right on top. Perfect. Okay, you can go ahead and have a seat. Now, what happens when you mix Alka-Seltzer and water? It bubbles and it fizzes. Now, what's happening is that it's a chemical reaction where the Alka-Seltzer is releasing carbon dioxide gas, which is what we breathe out. What we are going to do is we are going to rely on that gas to build up pressure inside of our rocket settling. Here we go. Now, with this one, we can't have a nice countdown because it is something called an uncontrolled explosion, meaning I don't know when it's going to go off, or even if it's going to go off. We just kind of have to wait and see. Now, while we can't count down, we can count up. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's bubbling. 21, 22, 23, 24, 25, 26, 27, 28, 29. Scrub it.
Yeah.
But I came prepared. You young ones may not know what this is.
Yeah.
For us older folks, I have a film canister. So we're going to give this one a try.
Definitely good work.
And this one should work. All right, same concept, looks a little bit different, less fancy, but it's going to